Mastering AWS CloudWatch, the architect's guide to production logging. Let's dive right in.
Picture this. You wake up at 7 a.m. Your phone is completely flooded with angry emails from customers. Your application crashed at exactly 3 a.m., locking out hundreds of users while you were asleep. Panic sets in. You scramble logging into the AWS console to figure out what went wrong, but your dashboard is completely empty. Here's the hard truth. Your system was warning you. You just weren't looking. Let me show you exactly how to debug these production failures and why logs are your absolute first source of truth when everything goes wrong. Before we dive into the AWS console, we need to understand exactly what we're looking for. When your application is running, it generates two distinct types of data: system logs and application logs. System logs are the underlying server telling you what it's doing. Things like, I just ran out of memory, or my CPU is maxed out. Application logs, on the other hand, are your custom code telling you what it's doing, like I successfully connected to the database, or, more importantly, user authentication failed. You absolutely need both to survive an outage. To capture all this crucial data in AWS, you use Amazon CloudWatch Logs. Simply put, CloudWatch Logs is a centralized repository that allows you to monitor, store, and access log files from your entire architecture in a highly scalable way. But AWS doesn't just take all of your text and throw it into one giant, unorganized bucket. That'd be a nightmare to search. Instead, it uses a very specific, strict architecture to keep you organized. Think about it like this. A log group is like a massive filing cabinet dedicated entirely to one specific application. If you have a billing app, it gets its own filing cabinet. Inside that massive filing cabinet, you have hundreds of individual folders. Those folders are your log streams. A log stream represents a sequence of log events from one specific source, like a single Amazon EC2 instance or one specific container running your code. It keeps the chaos organized. So how does the data actually get into those individual folders? Well, if you're using a managed service like AWS Lambda, the logging is beautifully automatic. AWS automatically creates a log group for your Lambda function and pushes all of your standard output and error messages directly into a log stream for you. But this is where people mess up. They launch an Amazon EC2 instance, they install their web application, and they just assume AWS is automatically capturing all their application logs. It's not. By default, CloudWatch has absolutely no visibility into the hard drive of an EC2 instance. To get those logs out, you must manually install and configure the CloudWatch agent on your server to actively push those log files into CloudWatch. Now here's where this gets really interesting. Just getting raw text into CloudWatch isn't enough to save you at 3 a.m. If your application is generating unstructured logs, meaning just massive raw sentences of text, you're literally going to spend hours scrolling through lines of code trying to find a single error. To engineer this correctly for production, you must use structured logging. You do this by formatting your log outputs as JSON. When your logs are structured as JSON key-value pairs, you unlock a massive feature called CloudWatch Logs Insights. Insights is an interactive query engine. It allows you to run fast, SQL-like queries across millions of log lines instantly. Instead of reading, you write a single query that says, show me every log where the status is 500 and the latency is over 2 seconds, and it will hand you the exact root cause of your 3 a.m. outage in milliseconds. Now, imagine this scenario. You don't want to wait until 7 a.m. to find out your app crashed. You don't want your customers telling you the system is down. You want AWS to catch the failure the exact second it happens. To do this proactively, you use a metric filter. A metric filter constantly and automatically scans your incoming log streams, evaluating the incoming text for specific terms, phrases, or values. For example, you tell it to look for the word exception. Every single time that word hits the log stream, the filter increments a custom CloudWatch metric. You then set a threshold. If that metric hits, say, 10 exceptions in 1 minute, it immediately triggers a CloudWatch alarm, waking you up at 3:01 a.m. so you can fix the issue before the users even notice. But what if you need to react even faster? If you need near real-time processing of your logs, you use a subscription filter. Instead of just counting words, a subscription filter takes your live, incoming log events and streams them directly into an Amazon Kinesis data stream or triggers an AWS Lambda function for instant, custom processing. This is exactly how you build truly self-healing architectures. Now, whether you're building this in the real world or studying for your AWS certification, watch out for these two massive exam traps on the DVA-C02. Let's dive into the first one. Trap number 1, log retention. By default, Amazon CloudWatch Logs retains your data indefinitely. Let me repeat that. It keeps it forever. If you have a high-traffic production application generating gigabytes or terabytes of logs every single day, and you leave the default settings on, your AWS bill will quietly explode. It's a massive pain point. To prevent this, you must explicitly configure a log retention policy on your log group, telling AWS to automatically delete or archive those older logs after a specific time frame, ranging anywhere from 1 day up to 10 years. Trap number 2, the missing logs mystery. Imagine you deploy a brand new Lambda function. It fails. You open up CloudWatch to read the error, but the log group does not exist. There are 0 logs. Where did they go? Why does this happen? Well, because AWS is completely locked down by default. Your Lambda function's execution role must have explicit IAM permissions attached to it, allowing it to write to CloudWatch. Specifically, it needs the logs create log group and logs put log events permissions. If you forget to give your compute resource explicit permission to write logs, AWS will silently drop every single error message your code generates. No warnings, no alerts. You will be completely blind during an outage. Let's lock this down. Here are your 3 rapid takeaways to master CloudWatch Logs. 1. Logs are your absolute first source of truth during an outage. Use log groups to organize your applications and log streams to track individual sources. 2. You must proactively manage your logs by installing the CloudWatch agent on EC2 instances, setting strict retention policies to avoid massive AWS bills, and ensuring your Lambda execution roles actually have the IAM permissions to write logs. 3. Implement structured JSON logging so you can instantly troubleshoot complex issues using CloudWatch Logs insights, and use metric filters to trigger alarms the very moment a specific error is written to the logs. I'll leave you with one final warning. If you aren't logging your application's state correctly, you aren't actually running a production system. You're just waiting for a disaster you can't explain. So, what invisible failures are hiding in your architecture right now?